Our next guest is a professor of mathematics in Notre Dame's College of Science. His research focuses on discrete probability, combinatorics, and graph theory. But don't worry, in this interview, we're going to stay out of those weeds and instead talk a little more broadly about math at Notre Dame and why we study math in the first place, something I really asked myself a lot in high school. Joining me now is Dr. David Galvin. Welcome, Dr. Galvin. Good to have you.
Thanks, Brandon. It's great to be here.
Oh, yeah. So I heard you were a huge hit in San Antonio during that Shamrock Series weekend. Tell us a little bit about that.
Yes, I went down with some colleagues from biology and computer science, and on the Friday morning, we got a chance to present our research to 1,100 middle schoolers. Ooh. It was a wonderful experience. The kids were full of energy, and they really engaged with our presentations. It was exciting to show them the variety of research opportunities in math and science. And a lot of the kids were from groups that are underrepresented in the sciences. I really think that events like this in the long run are going to help stem diversity.
Yeah, you worked with those kids. Can you explain to us a little bit about what you're working on like you would a kid? I'm going to be one of those elementary school students for a minute.
So a lot of the problems I work on involve counting, figuring out how many solutions there are to a problem and how that changes as some parameter of the problem changes. So in San Antonio, I talked about how many ways are there to walk around Manhattan with its grid streets without revisiting an intersection.
Okay.
And this seems like it might be just a recreational problem, but actually it has a lot of applications, for example, to protein folding, to the structure of polymers. It also is a model of the boundary of a rough crystal surface. And it turns out to be a very hard problem to answer exactly, because if you don't want to revisit an intersection, you have to keep track of the entire walk that you've taken to date, not just the last few steps. I really relish these kinds of problems that seem simple, but actually have a lot of complexity to them. And it's a great bonus that these problems have applications, but for me and for most mathematicians, the real draw is just the intellectual challenge of solving a hard problem.
And those real-world applications as well. Now, let's talk a little bit more broadly. I know a lot of people are kind of afraid of math, like me. So why is it important that we study it?
So Brandon, you could think about mathematics as the study of patterns. Patterns of motion, patterns of symmetry, patterns of shape. The world is filled with patterns, and mathematics gives us a language to talk about them. Sometimes you look at two problems and superficially they seem very different, but when you delve into them, you realize that they exhibit the same patterns. And that's really an exciting discovery because it deepens your understanding of both problems.
Oh, no doubt.
And now, because we teach our students the broad skills of searching for and understanding patterns, they end up being able to take their math degree and go off and do all kinds of things. They go into law, they go into finance, they go into medicine. They go really into very, very many fields. I do have to say, though, that it really helps our students that here at Notre Dame, I have so many colleagues who are really smart and really well respected. My colleague Sergei Sarchenko, he was recently awarded a Karp Prize for his outstanding work in logic.
Great.
Pavel Menev, who's just joined the department, he was this year's recipient of the Lukernovich Prize from the Max Planck Institute for his work in geometry. And Francois
really
Ladrapier was awarded a Grand Prix from the French Academy of Sciences for his work in dynamical systems. So we have
That's awesome.
We
Lots
have people
of great work happening
doing great work in the department.
Well, awesome. Thanks so much for joining us, Dr. Galvin. I promise I'm going to look at math a lot differently now.